Alright, I think this will work. Alright, I'm going to use this just in case, because sometimes when I go full screen it breaks. Alright, and it's recording my voice, and you'll get to hear me just fine. So let's take 247 in decimal. So, alright, 247 decimal, we're going to go straight across to two other systems. So, first, let's go and take that into octal. Now, the first question I have to ask myself is, now the last one we just simply asked how many 8s, but I have a feeling a higher power of 8 can go into 247. So let me just on the side of my paper here, because the test just begun and I'm being smart and I'm writing down stuff I know I'll forget. I'm going to write down the powers of 8. So of course the first one, 8 to the 0th, is 1. And I can go 8 to the first, which is 8. 8 to the second, which is 64. Make sure you don't think it's 16. 8 to the second is not 16. People make that mistake all the time. 64. And if we were to go ahead and multiply that out, we would see that our next one is not going to fit in here. So let's figure this out now. How many times does 64 go into 247? Well, I could use a calculator, but that's the coward's way. So we'll go 64, 128. And I'm just going to count it up to see. Well, actually, I should ask this first. What's the biggest power of 8 that fits into 247? We already said 64. That's how you start off. You ask, what's the biggest power of 8 that fits into that number? And of course, we keep going there, but I'm not going to give you any numbers bigger than this. All right, so the next thing, yes? Good. Yes, which we'll see in just a moment. I'll go and write the 3, yeah. But anyway, so this is the highest we can go, because if we go one more up, we get to 256. But 256 is bigger than 247, so we don't need to go that high. So 1, 2, 3. So we'll have 3 in the 64's place. 3 64s is what we need. And that's this number right here. So I noticed then that if I just represented 192 little rocks of the 247 little rocks, I can subtract that out. And you'll notice I get 55. Alright? So now I have to ask myself, I've done the 64s. There are no more 64s to put in. If I find that this number is divisible by 64, I need to stop and restart because I did something bad. Now, how many times is 8, the next power, go into 55? 6. Alright, so I understand that 6 times 8, if I were to write it out, 8, 16, 24. And this is just my preferred method. I like writing them out, just adding them down the row so that I know I don't miss any numbers. And I have this nice handy little sheet that I can keep reusing. So if I were to look at that, these are just some of the factors of 8. I'd go 1, 2, 3, 4, 5, 6. 48 is the biggest number, biggest power of, biggest factor. Factor? No, not factor. What is it called? Product? Multiple. Biggest multiple of 8 that fits into 48. 48 is the biggest multiple of 8 that fits into 55. And that's 6 8s. So I know that it's 3 6, and then there's one more space that I have to get. One more space, the ones place. So I take the 55 little rocks that I still have to represent. I take out 48 little rocks. I'm left with 7 little rocks, which you can see if I multiply out. Alright, so left with 7 little rocks to represent. So the next power of 8 that I have to represent is 1, right? So how many times is 1 going to 7? Easy. And that is how I put all that together, going from 247 to 367. And then I'm going to clear out some of this work. Lastly, I have to get into binary, which is going to be a huge, huge number. You guys notice how when I went from a larger base, the base 10, to a smaller base, base 8, I got a larger looking number. You know, I went from having a 2 on the left to having a 3 on the left. It looks bigger as we go down. This one's going to be gigantic. As I go from the from the larger base to the smaller base, the number looks bigger. The value is exactly the same. It just looks larger. Sort of. We might say a base of 1 is tally marks. But otherwise, we'll probably just leave that for what is it? Any power base 2 or higher. We won't worry about smaller than that. Alright, so as I said before, that cool math game, 2048, yeah, is because that's one of the powers of 2. So, guys, which number should I look at when I want to convert my number into binary? Should I look at decimal or octal? Which one do you think? Decimal. Why? Why do I want to look at decimal, y'all? So take a look at this. All these numbers over here. What base are these numbers in? These numbers themselves, y'all, are base 10. The numbers on the left side of the screen that I wrote there are the powers of 2, but they are written in base 10, right? This isn't 1, 1, 0, 1, 0, 0, so on and so forth. They are written in base 10. So if I'm trying to go, so I want to do base 10 to binary. So it's almost like I ignore the octal number now and just go straight into with decimal. Some of you, I think, tried to convert from octal to binary, and that took a while. So just like the octal number, let's look at this 247 decimal, and tell me, what's the biggest power of 2 that I wrote out here that fits into 247? 128, thank you. So we're going to take the 128's place. Now, obviously it only fits into it once, right? It can't fit into it twice. If you find that you get to a number and it fits into it twice, you're wrong. Retry. Because binary only has 1 and 0. So I'm going to go ahead and write the 1 for the 128. I'm going to check this off. And just like the octal number, I'm going to go ahead and see that out of the 247 little rocks, I have now represented, with that one stroke of the paintbrush, I have represented 128 rocks. So let me go ahead and, still using my wonderful top-down subtraction, I have 119 little rocks left to represent. So, can this 64 fit into that 119? Yeah, good. So I'm going to put that 1 right there. Now, with me representing out of the 119 little rocks, 64 little rocks, that means from now I need to represent 55 more little rocks. Does 32 fit into that 55? Cool. Alright, so if I have 55, and I know I'm moving around the page a lot, but if I have 55 little rocks, and I take out, and I've represented 32 of them, I'm left with 23 of them. 16 fits into it. So now these 23 little rocks, represented by 16 of them, and I'm left with having to represent 7 of them. Does 8 fit into 7? No. So I will mark it out, but I'm going to write a 0 here. That's the 8's place. Next, 4 does fit into it. Leaving me with 3. 2 fits into 3. 1 fits into 1. And there we are. 10s to 2s, 1s and 0s. We are all finished with that. And you'll notice that all those places that I checked off match those powers of 2 on the left. That this is the binary representation, because if we notice, here's the 1's place, the 2's place, the 4's place, the 8's place, which is 0, 16's, the 32's, the 64's, and the 1/28. And that if I were to quickly take the and add all these ones up together, you can see that I do actually get back to my 247. And that is decimal to octal and decimal to binary.